Our last unit of the year is going to deal with probability, which is the branch of math that measures the chance of something happening or an event happening. Probability can be expressed either as a fraction, a decimal, or a percent, somewhere between 0 and 1. Something with a 0% chance of happening is impossible. And something with a 100% chance of happening, or a 1 over 1 chance, is certain to happen. And then you can run the gamut in between 0 and 1. Now there's two different types of probability that we're going to be focusing on. Theoretical probability versus empirical or experimental probability. Theoretical probability is what should happen in theory. So for example, this coin that I have down at the bottom of the screen, if I were to flip that coin 10 times, I should get heads 5 times and tails 5 times. So my probability of heads would be 5 out of 10, or 0.5, or 50%, whichever way you want to look at it. And the same thing would be true of tails. If I get heads 5 times, I should get tails 5 times. And empirical or experimental probability is what actually happens when you carry out the experiment. So I'm going to come down here to the bottom, I'm going to flip the coin 10 times, and we're going to keep track of how many heads we end up with. So there's 1 tail, 2 tails, 1 head, 2 heads, 3 tails, 4 tails, 3 heads, 5 tails, 4 heads, 6 tails. So my experimental or my empirical probability came out different than my theoretical. My probability of tails ended up being 6 out of 10, or 0.6, or 60%. And my probability of heads, I only flipped heads 4 times out of 10, which is 0.4, or 40%. So the empirical may work out to be the same as theoretical, or it may work out to be different. If there's multiple parts to an experiment or multiple stages, sometimes a sample space is helpful, and the sample space shows all the possible outcomes of an experiment. So for example, if I were to take a coin and flip it 3 times, I'm going to draw a sample space that will show all my possible outcomes. The first coin, when I flip it up in the air, I could either get heads or tails. Then the second coin, when I flip it again, I could get heads or tails. I could get heads or tails after I flip the first head, or if I flipped a tail the first time, I could still flip heads or tails the second time. And then the same thing would be true on the third flip. Off of each one of those outcomes in the second stage, I could flip heads, tails. So I'm making ourselves a nice little tree diagram here. And then I can count, oh, I've got one outcome which goes heads, heads, heads. I've got another outcome that goes heads, heads, tails. I've got a third outcome that goes heads, tails, heads. a fourth outcome that goes heads, tails, tails. Then my other outcomes, tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. So I would have 8 outcomes to this experiment. So my probability of flipping 3 heads is 1 out of 8. And that would be my theoretical probability. If I actually carried the experiment out, I might not get 3 heads in 8 spins, or in 8 flips. The chance of me spinning 2 heads out of 3 is going to be out of 8. So here's one that I spun 2 heads, 2 heads, 2 heads, and that's it. So 3 of the outcomes had 2 heads in them. Theoretically, I should flip 2 heads 3 out of 8 times.